Hello student, today we will solve the problem 1.4 electrodynamic from J.D. Jackson book. The time average potential of neutral hydrogen atom is given by pi is equal to q e power minus alpha r divided by r into 1 plus alpha r divided by 2, where q is the magnitude of electronic charge and alpha power minus 1 is equal to a naught divided by 2 point the distribution of charge, both continuous and discrete, which will give this potential and interpret your result physically. So let's start the solution of this problem. So the given equation is problem number 1.4. The given equation is this portion q e power minus alpha r divided by r into 1 plus alpha r divided by 2. This is equation A, where this is Bohr radius. In this equation, alpha power minus 1 is Bohr radius. Okay. Now the required data we will find. Number first, charge distribution that produce the potential. First of all, we will find charge distribution that produce this potential, and number second, interpret the result physically. Interpret the result physically. Now solution start. General formula using Poisson's equation. We will write this. Where is my pen? So the general formula is which is given del square pi into r. This is equal to the negative rho divided by epsilon naught. The del square is Laplacian operator in spherical coordinate. This is Laplacian operator in spherical coordinate. For symmetric, for symmetric potential. This is del square, and the negative rho, this is density, and this is epsilon naught permittivity of free space. Now let this del square pi r will be equal to 1 over r square d by dr into d divided by dr. This is r square. This is equation number 2. This is equation 1. Okay. Equation 1, we will rewrite the equation 1, which is called Poisson's equation. Now this will become rho r which is equal to minus epsilon naught del pi r. This is equation 3. Okay, expand this equation A. Now we will expand this equation A, so it will become pi into r q, and this will become e power minus alpha r divided by r plus alpha e r divided by r divided by 2. Multiplying this into 1, and this term multiplied by a power ar divided by 2. So this is become equation 4. Taking derivative of this equation, so we will take the derivative of equation 4. This is become d pi divided by dr with respect to r, and this will become q d by dr into first term, which is e power minus alpha r divided by r, and the second term will be d by dr into alpha e power minus alpha r divided by 2. For first term, we will apply the derivative into this first term. This will become, for first term, the derivative will be equal to d by dr into e power minus alpha r divided by r. This will become equal to d by dr into alpha r into r minus 1, r power minus 1. This will be equal to minus this will be equal to minus alpha r divided by r, and this will be equal to minus e power minus alpha divided by r square. This is the first term that we apply the derivative. Now we will apply the derivative to the second term. Second term will be equal to d divided by second term, d by dr, and alpha e power minus alpha r divided by 2, which will be equal to minus alpha square e power minus alpha r and divided by 2. Now we will combine these both terms, this and this. Then the equation become, this is the equation. We will say this equation A. Now put this value for second term and this value for first term. So we will d pi divided by dr, which will become q minus alpha e into minus alpha r divided by r minus e alpha r divided by r square, and plus a minus will become minus, and alpha square e power minus alpha r divided by 2. This will become equation A. Now we will take second derivative of pi, which is equation 4. We will taking the second derivative of equation 4, which will be equal to second derivative of equation 4, which will become equal to d square pi. This is equation 5. Okay, d by r square, this is equal to q into d divided by dr. Sorry, r porn equation 5. We will take the derivative of this equation 5. This will become equal to d by dr into minus a e power minus alpha r, sorry r, this is alpha, minus e power alpha r divided by r square, and this will become alpha square e power minus alpha r divided by 2. Now apply this, we will apply derivative term by term. For first term we will apply for first term, then for second, and then for third. This is second and this is first term. Now for first term, d by dr minus alpha e power minus alpha r divided by t, which is divided by r, which is equal to alpha square e power minus alpha r divided by r plus alpha square, then this will become plus alpha and e power minus alpha r divided by, now this will become r square. This is for first term. Now we name this equation a. Now for second term, this will be equal to d by dr into minus e power minus alpha r divided by r square. This will give us, this is become minus 2. When we apply the derivative, this will become minus 2 e power alpha r divided by 2, sorry, r square, this will become r cube, and plus alpha e power minus alpha r divided by r square. This is second term. And for third term, we will apply derivative into third term, which is equal to d by dr into minus alpha square e power minus alpha r divided by 2. So this will become equal to, when we apply the derivative, this will become equal to alpha cube e power minus alpha r divided by 2. Now combine all terms to get d square alpha divided by dr square. Okay, now we will combine these all three terms in equation. Which equation? This is equation number 6. We will combine these equation a, b, and the equation, this will become equation c, and put in equation number 6. Now we will get this q alpha square e power minus alpha r divided by r plus alpha into e power minus alpha r divided by r square plus 2 into e power minus alpha r divided by r cube, and plus equation b, which is equal to alpha e power minus alpha r divided by r square, and the equation C, which is equal to alpha cube e power minus alpha r divided by 2. So we will simplify this equation as look at this term, this and this. This is the same terms. This is alpha and this is alpha. So this will give us 2 into this equation. Now we will rewrite this equation d square alpha pi divided by dr square, which is equal to, sorry yaar, this is q. This will become alpha square e power minus alpha r divided by r, and these both terms are added to get plus 2 alpha e power minus alpha r divided by r square and this will become as the same, 2 e power minus alpha r divided by r cube, and the other is alpha cube e power minus alpha r divided by 2. Now put this equation, let's say this is equation capital B. Put this equation in Poisson's equation, which will become equal to rho r, this is the Poisson's equation, del square pi into r. Put in this equation, we will get pi r equal to minus epsilon naught, and instead of this put we will get the equation alpha square e power minus alpha r divided by r plus 2 alpha e power minus alpha r divided by r square plus 2 e power minus alpha r divided by r cube plus alpha cube e power minus alpha r divided by 2. Now this is the final result for first condition, and now we will discuss the second condition, yani physical interpretation of this equation. Okay, this equation is, we will say that equation C. This is the final result, okay, for first condition. Now we will discuss the second part, in which we said that physical interpretation of this equation. Now physical interpretation, physical interpretation. If we see this equation, point 1 in physical interpretation, the term e power minus alpha r divided by r cube, and the other term which is e power minus alpha r divided by r square, and this term e power minus alpha r divided by r. These terms indicate the continuous charge distribution around the nucleus. Let's write this. These terms indicate continuous. Charge distribution. Distribution around the nucleus. The nucleus. It means that it represents electron cloud. It represents electron cloud. Electron cloud. And the second point will be the potential at R0 when we put R is equal to 0. Now let's write this. The potential at R is equal to 0. This will be correspond to discrete charge of nucleus. Correspond to the discrete charge of nucleus. Charge of nucleus, which act as a point charge. This charge will be is a point charge, which act as a point charge. So this was the problem that we solved today. If you have any question, please tell me in the comment section. Thank you.